we're not getting any dissent, then I think we'll kick off. And that leaves me to introduce Liam and Martin from Avanti. So it's going to be a bit of a twin operation here, isn't it? With the presentation on the Voyagers and the Pendolinos, and then Liam's going to take us on to some of the new fleets. So I'll hand over to both of you when you're ready.
Thanks very much, Tom. So yeah, thanks very much for inviting us here this evening. My name's Martin Ward. I'm the head of Fleet Technical at West Coast Partnership Development, which is actually the sister company of Avanti West Coast. So we're the shadow operator for high-speed services, HS2 in the future. And beside me, my colleague Liam will introduce himself, I'm sure, in more detail when I hand over to him shortly. So moving on then, so what are we going to run through this evening? Briefly, a bit about the background to the West Coast Partnership franchise, and then looking at the fleet and depot strategy as bid by the First Group and Trenitalia bid team. A question in particular about tilting trains. Of course, the existing operations are the Pendolino and Voyager tilting trains, and the question was, well, do we need more tilting trains, or can we actually operate non-tilting trains on the West Coast Main Line? Then we'll move on, and this is where I'll hand over to Liam to talk to us about the new trains project, the Class 805 and 807, and also about the major refurbishment of the Class 390 Pendolino fleet that we've undertaken over the last couple of years. And assuming we've got time at the end, I'll just briefly touch on what is my day job, HS2 and the West Coast fleet, and where we go from here. So the West Coast Partnership franchise, back in 2017, and by the time the ITT was released, 2018, it was a very different world. The DFT had some franchise objectives as published in the ITT. So it was all about growing passenger numbers, as any franchise ITT would ask. It's about growing the capacity, growing the usership of the railway, and growing the revenue. In particular, delivering a step change in the customer experience, particularly leading up to HS2, and with HS2 being a big, clearly a major project. They were looking for really stepping up customer experience on the West Coast, ready for the introduction of the high-speed services with HS2 opening. At the time, HS2 was due to open in 2026. So with the franchise due to start in 2019, that was just 7 years after franchise start. Of course, things have changed. It was about taking a once-in-a-lifetime opportunity to deliver a transformation, as I've said, with HS2 coming online, but also, and the clue is in the title of the franchise, being a partner for DFT, HS2, and Network Rail as the shadow operator in bringing together the plans for the future high-speed services and all of the other plans that need to be in place before you can integrate high-speed railway with the existing railway and launch such a huge endeavour. So that was the background to the ITT, delivering the benefits of the existing business, and remembering this was a huge franchise already. The West Coast franchise is already a huge franchise, and it was going to get substantially bigger with the addition of the high-speed services to the operations. And as I've mentioned, it was due to deliver that transition in 2026 with the opening of the first part of the high-speed services. So what did the world look like? Well, of course, it was pre-COVID. COVID-19 didn't really hit until early 2020. Of course, at the same time, this was pre any cuts to the HS2 network. So this is the classic Y network with the trains, or with the network, and therefore the trains ultimately serving Leeds and the East Coast Main Line, as well as East Midlands hub, as well as obviously Birmingham and Crewe and Manchester. So it was the full Y network that was planned. And alongside that, it was planned, of course, to have two fleets of high-speed trains, not only the first fleet of conventional rail network compatible trains for phase one, but also a subsequent procurement of some captive fleet that would operate solely on the high-speed network. So there was always intended to be two procurements of rolling stock for the high-speed services. An initial one, which was already underway. The train technical specification was out there already. HS2 was in the process of inviting tenders for the rolling stock at the point that we were bidding for the franchise. Other things going on. So in 2018, DfT challenged the rail industry to remove all diesel trains by 2040. And of course, if you know the West Coast Main Line and the train service, you'll know that the Voyagers operate not only to the parts of the network that are not fully electrified, but also they were operating London to Scotland services that are fully electrified. And that was clearly something that the government wanted to see resolved, so that we weren't operating diesel trains on an electric railway. So that's a bit about the background. Moving on then, what did we do in our bid? So I was the engineering sponsor for the first group Trenitalia bid, and we looked obviously initially at what's going on at the moment, as you would do in any franchise bid. What are the current fleets? So we've got the fleet of Pendolino trains, tilting trains that were introduced in around 2000, 2001, and also a fleet of Voyager diesel trains, operating, as I said, to the non-fully electrified parts of the network. Both fleets tilt, and both fleets were able to use the enhanced permissible speed, EPS, meaning that they can operate up to 125 miles an hour. In fact, originally Pendolino was intended to operate at 140 miles an hour, but things changed with the upgrade of the West Coast Main Line. So 125 mile an hour, but subject to them using the enhanced permissible speed and a system called TAS, the tilt authorization system. So that's the existing fleet that we had a look at and said, okay, well, that's what you've got at the moment. What do we think about that? Moving on then. Sorry, I was on the wrong slide then. I've just talked through the slide. So that's sorry, that's that slide with the existing fleets. Yes, talk about the maintenance and the servicing. So the Virgin Trains history had been to outsource the maintenance and servicing of both fleets. So Alstom undertook the maintenance and servicing of the Pendolino fleet. Bombardier were undertaking the maintenance and servicing of the Voyager fleet out of their Central Rivers depot. So that was the existing situation, and that was, of course, something that we also looked at. What are the pros and cons of that situation as we came in to look at what to bid for the franchise? So, typical questions you ask yourself when you're writing a franchise bid. What are the key drivers? So the DfT is looking for reduced cost. It's looking for sustainability, as I mentioned, improvement in the environmental situation. It's looking for growth in the number of seats, in the number of services, in the amount of revenue generated by the franchise. And it's looking to build services and the customer experience towards the HS2 launch. As the engineering team, we take our lead from two of the other teams within the franchise bid team. So there's a team working on what we call the train services team, the people who are thinking about the train service requirement, the timetable, the stopping patterns, the connectivity, the journey times, etc., etc. Where might we look to do additional services? Where might we look to change the situation with the current timetable? So they were saying, well, okay, we need this many seats, this many trains per hour, etc. So we get that driver from the train services team, and then also we get input from the customer experience team, who are looking at what's the customer offer on board. How do we need to improve the customer offer as compared to today? Do we need to provide new or upgraded systems, or different seating, different luggage provision, different catering offer? So we think about all of these things and think, what's the DfT want? What do the stakeholders want? What do the passengers need? And feed that in to what we need to do as the engineering team, the fleet team. So the key questions were, well, what should we do with the Voyagers? There was a fairly clear message that we should look to replace them with something more sustainable. What to do with the Pendolinos? Should we keep them or replace them? And if we keep them, how do we make them last for many more years to come? How do we add some capacity? And should we continue with the model of outsourcing the maintenance and servicing of the fleets? So having spent the 3 or 4 months you do when you're doing a franchise bid thinking about all of that, the outcome, the fleet plan that we ended up with was, the infographic on the top right shows there we had 56 Pendolinos, and the plan was to undertake a major refurbishment of those between, from franchise start, but recognizing there's a design period. So you actually start refurbishing about a year or 18 months into the franchise, and with an intention to complete that refurb by December 22. Then to replace the 20 Voyagers with 23 new trains. So partly a bi-mode fleet, recognizing that we still had the non-electrified parts of the network that we needed to go to. So 13 bi-mode trains met that requirement, and then supplemented by 10 purely electric trains to provide the additional capacity and also to fill in for the Voyagers operating on London-Scotland services. So 23 trains replaced 20 Voyagers, and those trains, the bi-modes are 5 cars, but the EMUs, the 10 EMUs, they're a 7-car train. Why only 7 cars? Well, actually, you get as many seats on a 7-car new 8300 train as you do on an existing 9-car Pendolino. So effectively, they're full-length trains, albeit they are only 7 cars long. And again, the intention was to get those introduced by December 22. Of course, this is at the point we were bidding the franchise, and of course, many things changed, having submitted the bid, having started the franchise, etc. So that was the plan. It didn't turn out like that, but Liam will tell us some more about that shortly. In terms of the number of seats, you can see there's a bit of a waterfall chart there on the bottom right diagram. So franchise starts something like 28,000 seats. The refurbishment of the Pendolino. Now, interestingly, we didn't add seats. We didn't squeeze more seats in. We put the same number of seats back, but we converted one of the vehicles within the Pendolino rate from a first class to a standard class. So we do actually add standard class seats, and we're looking at the standard class seat figure here. And then I said Voyager replacement with the new trains, because there are more new trains and more seats in the new trains, you get another extra set of seats there. So we get up to just over 32,000 seats as compared to the 28,000 standard class seats that were on the franchise in day one. So that's about a 5% more vehicles and 16% more standard class seats in the fleet. Of course, we looked at how to maintain the new trains. We determined that it's actually best to continue with the outsource model for the existing fleet. So we've continued with Alstom maintaining the Pendolinos. We continued with Bombardier maintaining the Voyagers, albeit that TSA contract will run down as we release the Voyagers from the fleet. And we have an arrangement whereby the new trains will be maintained out of Oxley. So there's, and again, Liam will talk more about those shortly. Moving on then, the question of whether or not new trains should tilt. Just a bit of background. So I mentioned we've got EPS and we've got PS. You can see a speed board there. So we've actually got a PS speed of 100 miles an hour. As it happens, in certain locations, there are 2 different speeds for EPS, in this case, 115 and 125, recognizing the slightly different characteristics of the Voyager and the Pendolino. So 115 and 125 are the speed limits for those 2 fleets, respectively. That's all determined by group standards. And you can only have at most 3 different speed limits on the network. So if you propose another speed, you would have to reduce the number of EPS speeds. So that was something that we had to bear in mind. As I said at the beginning, the EPS speeds are associated with vehicles fitted with this system called TAS, which is the case with the Voyagers and the Pendolinos. So how did we think we could go about replacing rolling stock without it being tilt then? Well, a bit of background. So up until Virgin Trains replaced the existing loco hauled stock, the locos were only 110 mile an hour capability anyway, albeit Mark III coaches were 125. So 110 across the network was just fine up until Virgin Trains did a complete fleet replacement in the early 2000s. At that point, EPS up to 125 was introduced for the Voyagers and the Pendolinos, and Virgin Trains had no interest in looking at the PS speed because all of their fleets were now operating at EPS. It almost was a bit of a barrier to competition on the route, because limiting PS speed to 110 means that journey times of a non-tilting train are obviously longer. So there was no incentive really to look at this, but we came along and thought, well, it must be possible to set a new speed profile to take better advantage of the applicable standards that apply to the cant efficiency and the rate of change of cant efficiency. Other railways, so East Coast Main Line, East Midlands Main Line, and Great Western Main Line have all got trains, non-tilting trains operating up to 125. So we started to look, what's the detail of how you would go about implementing a speed profile that was higher than PS, but not exceeding the limits of the applicable track standards and passenger comfort limits. And that took us into the line speed project. So we started by saying, well, what if we try to improve the sectional running times with this thing that we originally called PS Plus, a level of speed higher than PS, but not as fast as EPS. In combination with looking at making maximum use of the rates of change of cant efficiency and the cant efficiency itself, we also said, well, look, if you had a rolling stock fleet that accelerated more quickly than Voyager or Pendolino, that would also give you some savings on SRTs. So the combination of a careful look at how fast you can curve without exceeding track limits and comfort limits, and rolling stock fleets that better accelerate, can save you some seconds on sectional running times, and that was our approach. Having looked at all of that in some detail and gone quite a long way back into the research, back to the work that was done by the, as it says there, the BR track design team in the 50s, and then more recently by some of the research team in the 80s associated with APT. To make sure we fully understood it, we modeled the entirety of the route and developed a line speed profile to work out what speed we could operate. And this shows not the whole route. This is just the first 40 or so miles out of Euston. So you can see that the line speed is increasing as you leave London. And if you can see the colours there, the highest line is at 125. So that's the EPS speed profile. The lowest line there goes up to 110. So that's the PS speed profile. But the interesting one is the green line in between the blue and the orange. That's the maximum PS plus that we could run at, still within the track limits, cant efficiency limits, and the rate of change of cant limits. Having said that, you also have to consider, is that profile drivable? So a driver can't be changing speed too frequently. So there are rules about how frequently you can expect a driver to change the speed that they're driving at. But you can see from that immediately there's quite a lot of capacity to go faster than PS without exceeding the track limits. So that profile we then worked on all the way from London through to Weaver Junction, with the intention that the new plus 807 EMUs are aimed at the Liverpool services and elsewhere on the network, but we weren't intending to send the new trains north of Weaver Junction. So the line speed project so far has been undertaken between Euston and Weaver Junction. There is the potential to continue the analysis further north, and that's something that would be useful, of course, to HS2. But for the moment, that's as far as we've gone with it. On the next slide, we can just see this is a computer-generated image of what the speed limits will look like. So now we've got 110 is the PS speed. Instead of PS plus, what we've realized is that it's better to use the MU speed differential. So because the 805 and 807 will be designated or categorized as multiple unit MU, they'll be able to use MU as a differential speed. And that actually opens up the opportunity for other rolling stock that can be MU to also benefit from this analysis work that's been done. So now we're left with 110 PS, MU 125 and EPS 125. Of course, we've retained the Pendolino fleet, so we've still got EPS, but we'll have reduced or eliminated the Voyager fleet. So we've now just got one EPS speed and we've got an MU speed, which happens in this instance to be the same as EPS. Speed boards are going out on the network right now. Of course, at the moment, they've got bags over the boards, but there will be a date. Liam might know roughly when that is, or he might not. But at some stage, we will be implementing the differential speed running once we've done the driver training, etc. And that will then give us the benefits of the enhanced sectional running times. And in the table bottom right there, just give a bit of an indication of how much time is saved. So Pendolino EPS, Euston to Liverpool, not sure what the stopping pattern is, but whatever it is, it's the same in all three numbers. So 1 hour 58 and a half. If we were running at PS speed limits, it would be 2 hours and 8, so roughly 10 minutes longer. Whereas with MU differential speed, Class A to X does it in about 2 hours 3 and a half. So it's around half the time saving between PS and EPS is what we're getting with the MU line speed project. So it's not as good as EPS, but it's half as good. Half the time loss is gained back through the line speed project. I think at that point, I will stop and hand over. So at this point, we need to flip the slides, and Liam will jump in the seat because he's going to talk about the new trains project.
Good evening, everyone. My name's Liam Hockings, New Fleet Introduction Manager for Avanti West Coast. I've been with the project for coming up to 4 years now. First couple of years were with the MSA side, working with Hitachi, and then latterly moved into the business readiness, maintenance, mobilisation activities. So going to go over how the requirements of the fleet are met by the specification of the fleet, as Martin's pointed out, what the needs of the new fleet were. A look at the improvements we're making over the existing fleet and the evolution of the AT300 platform. This isn't exactly a carbon copy of the previous Class 800s. But with every change, there becomes a challenge. I'll go through some of the key technical challenges that we've had through the project. I'll move on to then where we are with the entry into service and some of the operational aspects that we need to cover to actually bring a new train fleet into service, and some of the operational and maintenance interfaces that we have with the project. Okay, and then I will go on to the Pendolino project at the end, which is swap back to the slides, the previous set of slides. So, key fleet requirements, as Martin has already mentioned. The diesel Voyagers were currently being used on electric and diesel routes. We needed rolling stock that could replace those. So obviously the bi-mode choice for the non-electrified network was a sensible one. But we've also been able to improve the emissions on the diesel routes. The Class 805s feature the latest Stage 5 emission compliant engine, which is an upgrade to the baseline AT300s, which we'll come on to in a little bit more detail. So not only are we removing diesel use, but where we continue to use diesel, we're lowering our emissions. We are providing additional capacity on existing services. So we are still running 5-car trains to North Wales. However, each train is longer in terms of the vehicle length. We've gone from a 23-metre to a 26-metre vehicle. So that does provide us with additional seating capacity per train. We've gone from 20 trains comprising 100 vehicles to 23 trains comprising 135 vehicles. And each of those vehicles is 3 metres longer than the vehicle they replace. So we've got longer vehicles, we've got more vehicles, and we've got more trains. So we're increasing capacity in every conceivable way possible. And as Martin's just mentioned there, we're doing our best to maintain journey times, but I think as importantly, it's about maintaining the route capacity on the West Coast main line with the introduction of the MU speed profile. So an important requirement of these trains was they were able to meet the weight requirements for an MU train, which they have done so, and the high acceleration capability of certainly the electric train is quite considerably higher than the 390 in the 0 to 60, 0 to 70 miles per hour acceleration. We've also improved the passenger environment. So in response to feedback from our customer experience team, we've got a whole range of new connected onboard systems. We've improved the catering offer on these trains, and we have the new standard class seats that are also being fitted to the Pendolinos. So I'll give you a quick overview of the makeup of each of the sub-fleets. So the 5-car bi-mode, 13 of these, 274 standard class seats across 4 vehicles, with the first class vehicle comprising 25 seats. In addition, this has 2 wheelchair locations and the UAT toilet. We've got bicycle storage for 4 bikes spread throughout the train, and we've added an additional toilet, so we have 5 toilets through the 5-car train as well. And in keeping similar to the offer of the Voyager, we have an onboard shop and a first-class galley in these trains as well. Trains can run in multiple, running up to 10 cars long. Because these vehicles are longer, our 10-car trains go up to 260 metres. Therefore, across the network, there's been a lot of additional work to ensure that we fit within platforms, within signals, and selective door operation, etc., which I'll come on to in a little bit more detail. So that's the 5-car bi-mode. The 7-car is it's a new configuration of the 800 series. So the 7-car formation hasn't been used before. So we have an additional trailer and motor car in the center of the train. And one of the interesting features of the AT300 platform, the additional center cars on the longer trains feature an inboard bearing bogie. So within our float of spares, we have 10 vehicles which have an inboard bearing bogey, and the other 125 have outboard bearing bogies. So there's a little bit of configuration management there. It was a technical question we asked as to whether that was absolutely necessary, but obviously when we're talking small numbers, the design is locked in. So in terms of overall layout, very similar to the 805. We've got 5.5 coaches, sorry, 6.5, 5.5 coaches of standard class. We've got a composite vehicle in the middle. I'm not sure if this mouse, does the mouse drive on the screen? I don't think it does it? I try and avoid the pointer for the, okay, let's do the laser pointer. So the first 5 vehicles, 5 vehicles are standard class. We have a composite vehicle here, which is a 50-50 split of first and standard, and that was to meet the aspirations of the increased standard seating numbers and reflecting the reduced amount of first class travel that we're seeing, which has resulted in one of the Pendolino first class vehicles being reseated to standard. So we were ensuring on this fleet that it reflected that overall split between standard and first. We still do have 49 first class seats, 2 wheelchair locations again in the first class vehicle. The main difference between the 7s and the 5s from a passenger point of view is the galley on the 7 car is equipped with a full service oven, hob, grill to provide a full catering as per the Pendolinos. Space constraints and sort of seating priorities has led to the 5 car having a sort of Voyager Plus kind of galley with the warming ovens and the toaster and the microwave. Both of the sets have 2 pantographs, 2 transformers, 2 sets of air compressors, distributed traction across the train. So there's multiple redundancy across the fleet in terms of maintaining continuous service. The main change from the 7 car to the majority of the previous 800 EMUs is this one is a pure EMU. There's no donkey engine, no single GU to provide that hotel power. I think my operating colleagues may have challenged that if they were involved in the bid stage, but that's one of the trade-offs that a bid team has to make between, I guess, overall costs and what they're trying to deliver to meet the franchise, to meet the specification of the DFT. But that has given us some operational workarounds that we need to do in terms of rescue and recovery, which I'll come on to a little bit later. So improvements and evolution, some of these have already been covered, but by introducing the bi-modes, we reduce our overall fuel usage goes down by 75%. And the stage 5 engine gives us a far cleaner exhaust output in terms of emissions, but also a significantly quieter onboard environment in diesel mode compared to the Voyager. It's a quieter engine. The sound insulation is a lot better. I don't think it vibrates quite as much as a Voyager does. So I think everyone's going to be happy there. TPWS Mark IV as standard. We have body side cameras on the fleet. We'll be using these as an addition to the existing dispatch method of work that we use. So we're not moving to a driver only operation. We will retain the train manager as part of the dispatch process, but the driver has the additional ability to monitor the dispatch corridor through the body side camera. So that's very much a safety enhancement. ETCS fitted, so as soon as Network Rail can provide the balises on the track, we're ready to go with ETCS, and it'll just work out the box, but that's coming later. And as with a lot of modern trains, we have integrated automatic selective door operation driven from database, GPS, and where required, balises in the track. The Voyagers on short platforms on North Wales do require the train manager to go out and manually lock doors when longer trains are operating. So that's another safety benefit. Capacity, we've increased on a 5 car, we've a 15% increase in seating. So on a like-for-like journey, that's an additional 50 seats. The 399 car, sorry, the 807 has 30 additional standard seats compared to a 399 car. So even on a 2 cars less, we're actually providing more standard class seats. And as I've said, the overall fleet size has gone up by 35 vehicles. So capacity increases across the board. Standard class seats, I'll come on to in a little bit more detail. That's been specifically designed for longer distance passenger comfort. We've looked at the interior configuration. There's a lot more bay tables, so families and groups can sit together, and most of those are very well aligned with the windows to provide everyone with a lovely view of our glorious countryside. And we've provided tables with inductive charging for mobile phones, 3-pin sockets, USB sockets, etc. And from a passenger point of view, all of the onboard systems are connected to the wayside, whether that be CCTV for incident review, PIS for live real-time train running updates, or real-time seat reservation updates for last-minute seat reservations. So quite a lot of improvements compared to our existing fleets. Some of these are being drip-fed into the Pendolino refurbishment, which I'll talk about shortly as well. And then in terms of the AT300 evolution, we do have quite a number of differences on this train compared to the baseline 800s, 802s. But in parallel to this build, we're running against the EMR 810s, which has a number of differences compared to our fleet. So there's quite a lot of change in the AT300 world. One of the big differences is the Stage 5 engine, and that's provided us with some interesting technical challenges, which I'll come on to. We've got a new high voltage transform, which builds in some of the earlier EMC mods that were required on the early fleets. The high acceleration rate in electric is retained for a slightly longer period. There's been some tweaks to the traction to meet the journey times and the sectional running, as Martin mentioned. Done a lot of work with the catering, so we've evolved the standard class shop offer that was fitted to the East Coast fleets, and we've opened that out into a more inviting, accessible area for standard class, and we've brought in some of our Pendolino equipment into the first class galley for a common approach. One of the bigger changes from technical systems is all of the passenger facing systems are now on their own separate data bus. That's all been removed from the TMS. So that provides us as an operator with far easier access to the data feeds to and from the train, and we are in control of what comes on and off the train far easier than the legacy builds, which everything had to go through TMS and through Hitachi, and it was a longer chain to get that information to and from the operator. Again, that brings with it its own set of challenges. And as I mentioned, the 7-car formation is a new one, so that required more braking tests and EMC tests, whereas the 5-car, we were able to use the previous brake test results. We didn't do anything other than a functional braking test, routine test, so that sped up the test program on the 5-car. So some of the technical challenges, just a selection, because we've only got a few hours. GU, big one, obviously. Existing fleets had a GU, so we've put the GU in the same place as the existing fleets. This one is a little bit bigger, it's a little bit heavier. The weight distribution has changed. We've increased the structural mounting points from 4 to 6, so various checks had to be done on the structure, but also the weight distribution of the train. The cooling system has gone from hydrostatic to electric, much more reliable. We've got a single piece radiator, which is much more reliable. One of the interesting things that came out of that is the electric supply to the cooling system actually comes from the onboard train auxiliaries rather than direct from the engine. So in the power changeover sequence, when the engine started up, it wasn't generating power to then go to the auxiliaries to come back to the cooling. So the engine instantly thought it was overheating and shut itself down. So that required some changes to the traction control software and the engine control software to allow it to generate electricity to come back onto the engine raft and actually fire up the cooling system to keep the engine cool. The changes to that, the changes to the aftercooler and the selective catalytic reduction, exhaust gases are burning a lot hotter, therefore the exhaust needed to be rerouted in the underframe to maintain sufficient separation. The power output of the engine for a given traction notch on the power brake controller was ever so slightly different. So a lot of reintegration of the power brake controller, the TMS, and the engine control need to be done as well. So quite a lot of work for say a like for like change, but the improvements have generated a lot of work to actually integrate that back into the vehicle and maintain the desired sort of traction curves that we were looking for. Passenger facing systems, there's quite a lot on this slide, but in summary, you have a number of systems that are integral to the TMS backbone on the existing fleets. The proposal was to remove all of those. So that includes the passenger information system, which includes the audio and the visual screens, but also the passenger alarms that are interfaced with the emergency brake, CCTV systems, the passenger counting systems, the seat reservation systems, and the addition of a new seat occupancy system. all of these systems were provided by a single supplier, and that was fitted with a standalone data bus on the train. So that was a lot of system architecture changes, because that still needed to talk to the rest of the train and still needed to send information to and from the train, still needed to interface with the TMS and the emergency brake, but it was a separate system now rather than integrated into the TMS. A lot of changes required there to both software, but also hardware as well. The actual modules that were fitted, slightly different sizes, different bracket arrangements, but also different cabling arrangements as well. So the substantial amounts of rework and rewiring design went into the early part of the assembly of the trains, as each of the modules needed slightly different cabling arrangements. And then when you start to fit seat occupancy detection, which features a sensor in every seat, that adds in a substantial amount of additional wiring that wasn't present on the original trains. We've also got this concept of a train crew app, where the train crew can have a mobile app. They can then actually connect to the onboard systems and carry out a number of the features and functions of the train from a mobile app. That brings, again, further challenges in terms of connectivity. Are you connected to the train? Are you connected to the internet, the Wi-Fi? What takes priority when the train manager needs to receive data from control, data protection, security of the device, and obviously technological advances that we need to bring our train crew colleagues along with. So lots of good things, but lots of challenges that need to be understood before we can actually bring these into use. Standard class seats, these are very similar to those fitted on the Lumo 803. They've been evolved ever so slightly to fit both the 390 and the 805s. A lot of research done by First Group to get the design of the seat as good as it could be, and has been engineered and ergonomically designed to provide longer distance comfort. So for longer journeys that these trains are typically going to be used for. Again, new seats, new slightly different arrangements, new tables required, new crash testing of both the seats and the tables. They come from different suppliers, different time frames, slightly different mounting arrangements between the 390 and the 807s. More testing required to make sure that the seats and their mounting arrangements were structurally safe and also provided the required secondary impact protection for passengers. As I mentioned just a second ago, we have a seat occupancy detection system, which is, I think, fairly new. This was specified for both the 390 and the 807. The 390 Alstom went with a camera-based system, tracking people's movements. Hitachi opted for a seat sensor system, so each seat has a pad in the seat which detects, I think, weight and movement, but also moisture, believe it or not. They are hardwired into a node box on the bottom of each seat, which is then wired back to a control on each vehicle. And we're told that each time one of those needs changing, it needs to be reconfigured so it knows the vehicle box knows which pad is linked to which seat number. So that brings in another maintenance change. The idea is seats that are reserved that don't get sat on after a period of time can be cleared from a reservation system. So when you get to the next station, that seat is then cleared. Also, seats that aren't reserved that are sat in can be shown as occupied on external systems, on station systems, etc., to direct passengers to areas of the train where there are more seats available. That's the theory. Obviously, a lot of data flows needed to go into making that work, and we are edging towards final versions of software development on there. Entry into service. This is a snapshot of activities that a train operator needs to go through to bring new trains into service. We've just sort of touched loosely on a couple of areas on the design and build area. I'm not going to go through all of these now because I'll still be here sometime tonight, but we've got to look at obviously the design and build of the train, the fleet and depot and maintenance strategies, development of training courses for train crew, drivers, train managers, caterers, fleet people, HQ, train planners, etc. We've got to deliver the training across all those while still trying to maintain a passenger service. We've got to look at how the trains operate within our stations. Are they longer? Are the doors in the same place? Operational changes. We've got power changeover on these trains. We've got new TMS. We've got body side cameras. All of that has to go through a period of development, consultation, and then a safety validation exercise where all of the risk assessments of the hazards that are identified with the train are demonstrated to have been mitigated and closed out before we can internally put those trains into service. We also receive authority from the rail regulator to put trains into service as well. So aside from the vehicles, there's a huge amount of work that an operator has to go through before trains can go into service. And at various stages through the project, you find yourself sort of pushing things uphill. You get various challenges thrown your way, such as pandemics, various industry IR issues that have been going on at the moment. Other things come at you, surprises. We during the design of this train, there was the fairly well publicized body shell issue with the Hitachi vehicles that we've had to try and build into our program. And then things become real. Trains start turning up at depots, and people realize this isn't going to go away. The new trains are here. They're shiny. They're real. People start to get excited, and impending lease end of existing trains, and suddenly we unblock and things start to move, and we are pretty much at the point where we are starting driver training in a classroom sense very imminently. So these trains will be coming through Milton Keynes in the not too distant future, said a spokesman. Just a couple of the quick things that we've had to do. A lot of stations where we interface with a huge number of other operators, many of which are introducing their own trains. There's a bit of a harmonization exercise across the industry to try and reduce this clutter that we see at the end of the platforms, and God help the poor driver trying to decide which one he's going to follow today. One of my colleagues has been to many of these stations, and every time he goes, there's a new sign that another operator's put there. And despite trying to work in collaboration, we're still having that challenge. I think eventually we'll just have one big board at the end that will say S, and we'll all stop at the same place. But we'll see about that. So he reckons he's done over 30 miles, but I think he's probably more like 50 now because he keeps going back and doing other things. But it's very important to get this right. We operate some fairly long trains that are as long as a Pendolino. We do have some selective door operation, but all the wheelchair positions, the cycle positions, the catering, ever so slightly different. We have some oddities. We have benches, litter bins, bits of bridge, bits of stanchion. If you get it wrong, you end up with a wheelchair ramp, and you can't board a passenger in a wheelchair, and that's a bad news story. So a lot of effort goes into making sure all these things are right before the trains can come into service. And it's produced some wonderful diagrams. Which this is Chester Station. Platform 3, we do a lot of coupling and joining of the 5s and the 10s here. We've got a mid-platform crossover. We've got TPWS grids. We've got loads of other signage, and we've got to work out, is it going to fit, and is it going to move when we park over the TPWS grid? So it's a bit of a snapshot of some of the work that's gone on there. Operations and maintenance, really very quickly on this one. I think following the model Martin described of outsourced maintenance, we've ended up with a bit of a hybrid here. So instead of Hitachi providing all of that service to us, as we see with Alstom on the 390s and as Hitachi do on the other AT300 fleets, we have split that work. Relatively small fleet, and in terms of building depots for small fleets, that becomes quite an expensive proposition. Therefore, we have contracted Alstom to deliver all of the planned maintenance, cleaning activities and fleet planning from Oxley Depot, where there was identified to be some spare capacity, and we've contracted with Hitachi to provide all the technical support and all of the spares under a TSSA, and those parties and ourselves work together collaboratively through an interworking agreement. Quickly onto the services. 5 cars will provide all of the services through to Chester, North Wales and Holyhead. The 7 cars, the bulk of the fleet, will be used to provide an additional train per hour to Liverpool. So alongside the Pendolinos, that whole the end state is a 2 train per hour service to Liverpool. And then we've recast our Birmingham services. So we have two services per hour that are fast to Coventry in the end state, which would be 390s. And then we have what's called the connectivity train, which is Watford, Milton Keynes, Rugby in addition, and that will be provided by mostly 807s, but we have a pair of 805s on that diagram as well. And then a couple of services to Blackpool. So although the trains will be technically compatible and route cleared to operate to Manchester and to Scotland, they have technical compatibility. We're not doing any preparation work for those. So Pendolinos will continue to serve all of Manchester, and Scotland, both the direct and via Birmingham services. And we are using all existing maintenance depots. So we're not building any new depots, but there is a little bit of upgrade work for the depots. Just very quickly, power changeover. The train is very capable. You can do power changeover at speed up to 125. You can do it stationary. You can do it automated through the use of balises and databases, or you can do it manually where the driver presses a button. Our operation in terms of power changeover is fairly straightforward. All the services to Shrewsbury through Wolverhampton, we'll call it Wolverhampton, so we'll do a manual power changeover there. And all the services through to Chester and North Wales, call it Crewe. So we've elected to do a manual stationary change at Crewe as well. Some of the reasons for that, both of those locations have depots. So this is Oxley Depot here. We have a diesel route to Shrewsbury. We have an electric route to Birmingham. And we have this lovely bit of railway here called the Oxley Cord, which is non-electrified. We have some wonderful services. One comes in from Stafford on electric, terminates at Birmingham, goes round the back of Birmingham, comes out here, pops in a loop here, changes ends, drops the pan and runs over the cord. So I just think everyone just looked at that and thought, no, we can't automate that. It's going to lead to far too many problems. But it's the depot areas that give us challenge in terms of automating. This is Crewe, so we mostly operate to Chester on diesel. The depot is on an electrified route, but the sidings that we are able to park these trains on are diesel. So again, trying to automate that in terms of trains coming on in electric, but then needing to switch to diesel, being prepped in diesel, but they need to go on to electric or diesel, depending on where they're heading. Again, it was deemed to be a simpler mode of operation to do that manually and provide instruction to the driver as to which power mode to select. So we've elected with Mark 1 Human for that. So just in terms of the new trains, we have improved the capability of the fleet through the buy mode, improved the cleanliness through operating a cleaner diesel and much more electric, increased the capacity and the comfort of the passengers, and provided that additional connectivity through the connected systems we've got on board. So a big step change in a number of areas that the new trains will bring to the West Coast. So just a quick overview of the Class 390 refurbishment. Put this into context. So Pendolinos, a very iconic flagship fleet of the West Coast, have been in service now for approaching 20 years. It was deemed to the best course of action retain that fleet and invest in its future to bring it up to modern standards. So some of the specification for that in a £120 million investment included brand new seats in standard class and a thorough overhaul of the first class seats. Brand new tables with wireless charging throughout, inductive charging for phones, and bringing in charging sockets to every seat on the train. That was probably one of the bigger passenger areas that this fleet was missing, was the provision of charging sockets, especially at the airline seats. New carpets throughout, brand new CCTV, so higher resolution cameras and better coverage. The existing shop was replaced, a new cafe bar, a much more open, spacious area. The intention of this was very much to sort of promote a social interaction, which obviously came into question when COVID hit and everything had to be changed slightly. But that was the design aspiration behind the new cafe bar rather than a shop environment. And on the 11 cars, the train still retained 4 first-class vehicles prior to the refurbishment. So one of those was converted to a standard class vehicle. So now we have across the 9 and the 11 cars a uniform provision of 3 first-class vehicles, and then and the rest being a standard class. So what we're also promoting now on most of our services, one of those first class vehicles is actually sold as a standard premium. So it's the first class seating and environment, but there's no provision of food or drinks. That's a supplement. The lighting's been replaced, so LED lighting, so much more energy efficient and a more slightly fresher tone to the lighting on board. Various panels have been refurbished. The vestibules have also been refreshed as well to give those a much more up-to-date sort of cool color palette. New media screens have been fitted to the bulkheads of each vehicle, so that provides onboard sort of real-time journey information, next station information, tube line information, also information about CCTV on board to provide a security deterrent. Additional luggage space. So on the 11 cars, a couple of pairs of seats have been removed on certain vehicles with larger luggage racks fitted, and some additional accessibility features. So in the wheelchair area, carpet has a very large, very prominent wheelchair logo on the floor, so it's fairly obvious when people start to put bags on it that they shouldn't be there. And then in the first class area, some additional partitions between the seat backs to provide a more private environment. Obviously, we can't do this on our own. It's a huge collaboration. Angel Trains did a lot of the development work of this. Obviously, they're very interested in keeping the 390s on lease, so they invested a lot of the original concepts and design work, and that fed into our bid. And Alstom are the manufacturer of the fleet, the maintainer of the fleet as well. We also used their Widnes site for the vast majority of this work, and it's been a big collaborative exercise to get those trains in there and achieve what is a fairly demanding 2-week beat rate for each train set going in, and having that level of work done across either 9 or 11 vehicles within 2 weeks. A lot of the supply base has come from the UK, so 59 out of the 68 key suppliers are UK based, and 80% of the project spend has been within the UK. So there's been a big focus on local supply, and the train has won a number of awards through the refurbishment program, and it's been a big success. It is the biggest fleet refurbishment program ever to be undertaken in the UK. 574 vehicles, which is a huge number of vehicles. Not quite as many as Malcolm's S stock he alluded to earlier, 1,400, but we'll get there. As Martin said, franchise started back end of 2019, so this was first off the blocks to go into the design phase. Got a couple of months down the line and COVID hit. Therefore, a lot of the design activities that would have been in a office environment in a collaborative sense had to move to a remote setting, which was obviously fairly new to everyone. Quite challenging, put a lot of pressure on the design teams, but they rose to the challenge and have come up with a really high quality refurbishment. Obviously, what we're trying to do in the background was run a train service. Our intention was to only release one train to this program, and that train comes back in 2 weeks, and we continue to provide the train service. As with a lot of refurbs, the early stages do involve learning. There was learning built into the program. It was never quite enough, and it was quite a challenge at the beginning to actually undertake this in the 2 weeks. But Alstom invested a lot of time and effort in terms of looking at their processes, their headcount, how they resource the project, how the material came into the program, and actually got that down to that 14-week beat rate. I think fairly early on in the program, that's been maintained ever since, and we are on track to finish in June of this year. So we're on to the sort of the final stretch of the 9 cars. So a much more modern, fresh interior. Those of you living in Milton Keynes hopefully will have travelled on one of these in the recent past. A massive transformation to the environment in the Pendolino, and interesting. Our customer feedback metrics have been incredibly positive. A lot of customers recognising the benefits of the work, feeling like it's a brand new train. And interestingly, this is borne out in the customer survey. So over a given period of time, the orange line is our typical feedback with a non-refurbished train. So you can see there are highs and lows, which reflected wider issues. But if those same experiences happened on a refurbished train, the scores were notably higher, even though there was those external impacts. So it does make a difference to the passengers' overall perception of the journey. Achievements and awards. Massive project, huge collaboration. Fleet has won a couple of awards. It's won Fleet Achievement of the Year award at the National Rail Awards and Large Scale Project Award at the 2023 Rail Innovation Awards. So not only has it been hugely successful for us as a business and the passengers, but the teams involved have been recognised for their efforts as well. So it's been highly successful all round. So that concludes the new trains and the refurbished Pendolino sections. Martin's going to come back now and hopefully give you a little bit of an update on HS2.
Yeah, I've just got literally one slide, so
Okay.
sit tight there, Liam.
Yep, perfect.
We couldn't really do a discussion of fleet on the West Coast without at least mentioning HS2. And of course, we write a fleet plan at the beginning of the franchise, and then we've talked a lot about delivery of that fleet plan and the strategy. But of course, HS2 has changed hugely since we took on the franchise. So it's no longer opening in 2026. It's now more like 2030, 2031 before the first stage opens. In the last few months, there's been the announcement by the Prime Minister that phase 2 won't in fact happen. So our thinking about plans for high-speed services have had to change completely. And indeed, that's work that we're doing right now is to ask questions like, well, what does that mean for the new train service pattern? What does that mean for the need for residual rolling stock requirements to supplement the high-speed services? Franchise is all about integrating the high speed with the what we might call the intercity services. So we don't treat them separately. We say, as an integrated fleet, what does it look like? What services can we run? What capacity do we provide? What connectivity do we provide, etc. And of course, there's the issue of now needing to run all of the high-speed services over Handsacre rather than having the phase 2A route to Crewe. So we've now got the whole question of what is the capacity of that junction and the junctions just up the railway from it. What does that mean for the number of trains per hour? What does that mean? You know, it's been in the news recently, hasn't it, about the capacity to Manchester and the capacity to Scotland. We're replacing a 265-metre Pendolino with a 200-metre HS2 unit. Clearly, that's a problem. It won't have as many seats. So questions are being asked about how we're going to resolve that sort of thing as well. Of course, the original intention was HS2 would be 200 and 400-metre trains, but there is now no longer going to be a 400-metre platform in Manchester for us to use. So we need to look at how best can we increase capacity to Manchester and indeed cities and the north end of the West Coast main line with HS2 rolling stock. And what, if anything, do we need to change about the plans that we've been making over the last few years? So I think without going any further, I'll just leave it at that. I'm welcome any questions on HS2 as well as the other stuff that we've talked about. Thank you.
Yeah, thanks very much. And I think what's clear from that final slide and from some of the points that were covered about the 8300 introduction and the Pendolino refurbishment is how the picture can be very different when you come to actually introducing a train versus what the situation is when you're at contract signing, and it seems to be a bit of a common theme there. Thanks to Liam and Martin for coming to give us what I thought was a really comprehensive overview of the work that's being done at the moment and the work for the future in at Avanti West Coast. I thought it was really interesting having the new fleet introduction in parallel to what's being done in terms of the renovation on the Pendolinos. We touched on before. I thought it was really interesting seeing the various cases, how from signing contracts to introduction, how the landscape changes and how you've adjusted that with things such as standard premium and the introduction of quite innovative ideas when it comes to operations. And just giving us an overview of how much of a balancing act it is between technical, between operational. It's no secret I've been involved with some of the technical work, but I don't see a lot of the operational. Yeah. So it's I've only seen what is a very small part of it. So getting that 360 view has been certainly very interesting. So that's it from me. I just wanted to say thanks again. Thanks again to everyone in the room and online. Our next session will be on the 22nd of February for the Future of Rail. And have a very good evening.